Question 5. You're hot, you're going to go for a swim. You bring your cat. You're going to decide to go to a bridge that you can jump off of. You're going to push away from the bridge horizontally as you jump with some initial velocity in the x direction. Your cat isn't really paying attention and it just steps off the edge of the bridge at the exact same time. We're at a neglect air resistance like we usually do. Which one, only one, of the following happens? Okay, so here you are. Here's the bridge that you're on. Okay, you're going to push off this way, so you're going to fall into the water. Your cat the cat's over here on this side, and it just falls off. So it's going to go straight down and into the water. So let's see. Your only options are the cat enters the water first. Does the cat make it down there faster or slower than you? You enter the water first, so you're faster than the cat. You both will enter the water at the exact same time. So this distance and this distance will be traveled in the same amount of time. You'll enter the water with the same velocities, or you'll enter the water with the same speeds. Okay. So first, it's like the helicopter problem from before. Now we're looking at the y direction instead of the x direction. Okay. So we need to look at the y direction of the cat. The cat will accelerate downward with an acceleration of negative 9.8. Initial velocity of the cat, 0. Change in y is the height of the bridge. Let's say the bridge is, well, I'll just say h, whatever the height of the bridge is. And it would be negative because it's falling down. And t is what we'd be interested in. Okay. If we do one over here for your person, they also travel a distance negative h in the y direction only. Okay. Their initial velocity in the y direction is 0. Their acceleration is also negative 9.8 because they're traveling with gravity pulling them down the same. Final velocity on this is definitely not 0. Same on this one, definitely not 0. So the time is the first one we're interested in. Being these numbers are all the same, time, if we factor it in, if we look at the equation that doesn't have VF in it, we can punch in and go with change in y is equal to VIT plus 1/2 AT squared. If we plug that in for both of these, we'll end up with the exact same answer regardless of what h is. So one is the cat enters the water first, no way. You enter the water first, no way. You both enter the water at the same time. So we know this one must be true. Now, just for process of elimination, just to make sure everything looks good, you both enter the water with the same velocity. Incorrect. This one, when it enters the water, your cat will only have a velocity in the y direction, whatever that is. You, on the other hand, will also have whatever this was. You will also have a x component of velocity. So you will not enter with the same velocity because yours will have 2 components, whereas your cat only has the 1 component. And it's the same for speed. It doesn't matter whether we do this in vector form or if I look at component-wise. If I do Pythagorean theorem on this, I'm just going to have 1 value to square, whereas if I do Pythagorean theorem on yours, I'll have 2 values to square. So you will enter the water with a higher velocity than the cat always, and thus a higher speed. So both of these cannot occur.